We have a question that states, you are ventilating a patient at the following settings. The mode is volume targeted assist control with a respiratory rate of 15, peak inspiratory pressure of 25, peak flow of 60 in a square waveform pattern with a PEEP of 10 and a tidal volume of 500. And we're being asked to sketch and label the pressure, flow, and volume versus time waveforms. We're going to go through the steps of this with this volume targeted assist control mode. Our first step is to calculate total time. So to calculate total time, I know that I have 60 seconds in a minute, and I have a respiratory rate of 15 that was given to me. So in order to calculate my total time, I'm going to take 60 seconds, divide that by 15, which was my respiratory rate, and so I get a total time of 4 seconds. Our second step is one of the harder steps, because now that we've calculated our total time, we have to calculate our I time. In order to do that, we have to remember this formula. Flow is equal to the change in volume over our inspiratory time. Okay, we need to get TI alone. In order to do that, we will multiply this side by TI. What we do to one side, we do to the other. That'll cancel out, and we have TI on this side. Now we still need to get TI alone, so in order to do that, we will divide this side by flow, and we'll do the same thing to this side. Flow cancels out, and we're left with TI is equal to a change in volume over flow. Now we're going to plug in the numbers that were given to us. So again, we know TI is a change in volume. We're given the 500 milliliter tidal volume and a flow rate of 60 liters a minute. We can't divide a fraction, so we have to multiply it. In order to do this, we're going to have to flip the denominator in this process. So to do that, we have TI is equal to 500 milliliters times 1 minute and 60 liters. So really from here what we're going to do is it's a process of canceling our units. So we need to get minutes out. So we say 1 minute is equal to 60 seconds. The other thing we need to cancel out is our milliliters. So we say 1,000 milliliters is equal to 1 liter. Then we can go ahead and cancel our milliliters, cancel our liters, cancel our minutes, and we will be left with our answer in seconds. If we work this out on our calculator, we're going to find TI is equal to, sorry about that, is equal to 0.5 seconds. Okay, our last step now is the waveforms. So if we are in volume targeted with a square waveform, or with a square flow waveform, we know that if we have a square flow waveform, that's going to look like something like that. If we're in a square flow waveform, we know that pressure will be linear, so it's going to look something like this. And we know that volume is also going to be linear, so volume flow waveform will look something like that. Okay, the last step in this is to draw this out to scale. So Olga did a really good job here. So we start with our pressure waveform here at the top. The thing that we have to make sure we do is label our parts. So see there where she labeled centimeters of water pressure. So she has, in this equation, we had 10 centimeters of PEEP. So we see that that's drawn in with what was our high? Our peak inspiratory pressure was 25, so that's labeled right about there at 25. On the bottom here, we have our time scale done. So we see here that the inspiratory time, or the TI, was 0.5. So that's labeled there, and that traces right up along to all of our waveforms matching up there. We also labeled here on the bottom our total time, which was 4 seconds for each breath. When we went to the flow waveform, again, we labeled peak flow at 60 liters a minute, again in that square waveform, and she made sure to label the units there also. On our volume waveform, again, we had that linear volume waveform. We have a volume there of 500, so it goes up to 500 in the point, and those are correctly labeled.